Now these are both applications of definite integrals that we have covered before, but we're just going to revisit them now that we're actually doing the definite integrals exactly with these formulas that we have. So if we're told to find the area under a curve, let's kind of just draw out what this means for a second, try to remind ourselves of some of this. So we'll have 6x squared, so here's my axis, and 6x squared is a parabola, and it looks something like this. Now, when it says find the area between x equals 2 and x equals 7, I would draw out 2 and 7, and then I would just shade all this in. I'm trying to find this area right here. The way we've done it before is we've kind of drawn some rectangles, maybe we've used our calculator. Those are both not what we're trying to do here. What we want to do is we actually want to compute it exactly. Now, the way we do it is all we have to do is set up our definite integral, and it's really helpful to know that the integral between 2 and 7 of 6x squared, this thing, is really just finding the area under the curve between 2 and 7 of 6x squared. It also has that meaning, right? So all we have to do here is use the technique we got from this section to do it exactly. So we'll have 6 integral from 2 to 7 of x squared dx. Using our formulas, we'll get 6x cubed over 3 from x equals 7 to x equals 2. So if you want to actually work this out, for x equals 7, you will have 6 times 7 cubed over 3. And for x equals 2, you'll have 6 times 2 cubed over 3. Now if you type both these into your calculator, you'll get 686 minus 16, which of course is 670. So this would be the answer you put into WebWork. This is that area computed out exactly. And so this is just the way we'll be doing it whenever we can, which is when they give us a formula, right? And you should practice doing it this way because they can make it so that you can't type it in your calculator by maybe putting like an a here or something like that, an ax squared rather than a 6x squared. And then you'd actually be able to work this out. Now, the other application of definite integrals that we have covered, but we're just going to revisit again, is if they give us a rate. So here we have a swimming pool that's filling up at a certain rate in gallons per hour. So let's kind of remember what this means. At x equals 0, so or at t equals 0, r of 0 is going to be 0 squared plus 1, which is 1, which tells us at this point, the hose that's filling up the pool is filling it up at about a gallon per hour. Really slowly, right? So over the next hour, we'll dump about a gallon of water into the pool. It's just like at a trickle at this point. Now, as time goes on, it's going to be filling up the pool faster, but the question isn't asking us about how fast the pool is being filled up. It says how many gallons were put in the swimming pool between t equals 2 and t equals 5. So this thing here is a rate. And now this, how many gallons, it's not how many gallons per hour, this is not a rate. How many gallons is just, that's a total change, right? And so what we had practiced in previous sections was that if we integrate a rate from 2 to 5, we'll get the total change from between t equals 2 and t equals 5. So how we would do this problem then is we would say, all right, then we take the integral from 2 to 5 of x squared plus 1. And sorry for mixing up the x's and the t's here. I'll change that to a t. Say from t squared plus 1 dt from 2 to 5 is going to be the answer I want. Now, how do I actually do this? So this is going to be the t cubed over 3 plus t between t equals 5 and t equals 2. Now, if I actually work this out, so I'll have 5 cubed over 3 plus 5. That's for t equals 5, and I subtract that from t equals 2. So 2 cubed over 3 plus 5. And before I got to change this to a 2 first, because it's t cubed over 3 plus t. So now what I actually have is correct. But you would get 46.66 minus 4.66, which if you work that out, it is just 40 gallons. Okay, so integrate a rate of change, and you will get the total change if you put those bounds on your integral.